Hello, the purpose of this presentation is to demonstrate the use of regression in Excel, or I should say the use of Excel in regression. And this is meant for those of you who do not have experience in, again, using Excel to do regression analysis. For some of you, it may be unnecessary, so you could skip this video, but in any case, it'll be a relatively short overview, and it will be geared specifically to the kind of things we're going to do in Module 5. So I'm going to start out with, rather than have a data set that I'll need to make available to everyone to kind of play along with this presentation, I'm just going to create some data just off the top of my head here. So I'm going to go to here to A1. I'm going to call this the X variable. And I'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's say there's 12 numbers. Then they're going to have the Y variable. And again, I'm just going to make some numbers up. 54, 47, 65, 64, 2, 58, 69, 73, 71, 80, 78, 84, 91. Okay, now I'm going to just, it's funny how Excel does this formatting where it right justifies letters and left justifies letters and right justifies numbers. And so when you don't take specific action, it ends up being kind of a cockeyed situation. But anyway, so it's always a good idea in the two-dimensional case just to do a simple graph of the values, a scatter plot, just to kind of see what we're dealing with. And so if we come over here to, to insert, we go over to the scatter plot. We want the scatter plot. Okay, so you see here that we do have a situation where we see kind of a trend. It looks like regression model would fit these data nicely. It looks like it's linear. And I'm not going to do any kind of crazy formatting on this, but you know that the horizontal axis here is the X and the vertical axis is the Y. We can see that from over here. And I should really rescale the Y axis here just to see the values better, but I'm just not going to do that right now. All right, so we want to set up a regression equation. Now I know some of you know that if you click on one of the data points here and you right click, you could say add a trend line. And the default is linear. And you could even do things like display the equation on the chart, which is down here. You can click off of that. I'll close this thing over here. And so we can move this a little bit just so we can see it better. So you see that we have 3.3706 times x plus 47.424 is the regression equation. Now there's two problems with that using this approach, and it's actually a good approach to do quickly. One problem is that those values, the 33.3706 and the 47.424, are not located anywhere in the spreadsheet. So to use those in a follow-up calculation, you would have to actually just intervene manually, which is, not a great situation. The second reason that it's not a perfect solution here for regression is there's a lot of information that it does not include that we might want to include in a normal situation. So, and you'll see that in a few minutes. So let's be happy with this though. In fact, we'll move it down here. That should work out. So here's how we do regression. We go to data, data analysis. And by the way, if that's not there, if the data analysis routine is not there, you would have to come over to File, Options, Add-ins, it's working. I just have something running in the background that's slowing me down here. All right, and over here, Excel add-ins go. and see over here where it says Analysis Tool Pack, and there's a check. If you did not have the data analysis routines under the Data tab, or Data menu item, then you would put a check mark here and hit OK. I'll just hit cancel, and if you did that, it would just appear there. So here, anyway, here it is. I'll hit Data Analysis, and there's a lot of routines here, and one of them is regression. Okay, the Y range is the vertical axis, so I will grab these numbers here. The X range is the horizontal axis. I'll grab these numbers here. Now, after I did that, you may have noticed that I did not grab row 1. If I did, I would have checked labels here to let Excel know that the first row in each of those ranges was a label, not a number, because sometimes a label is a number, like a part number, so you don't want it to be confused. Now I'm going to check that off here because I did not choose those within the regression. You may be asking why, and the only reason I didn't do that is because in the module, when we do our deseasonalization of our demand where we'll use regression, it turns out that we can't use labels in that, and so it's not a big deal. I didn't really have to say too much about that. So down here under output range, you have a choice between putting into a new workbook, a new tab, which they call apply within this workbook, or somewhere in this same spreadsheet. I'm going to put it in D1. Now when I say put it in D1, what that means is you're going to get a table here, and that's going to be the top left, and I think the graph will be out of the way here. So let's hit OK. And it says X and Y range must have the same number of rows. So I made a mistake, and I notice here that if I do this, you notice it says B2 to B14, and it should be actually down to B13. So look at that, instead B14 again. Let me just fix that. Okay, it's B13, so I can fix that. Okay, good. Hit OK. And what else did I do wrong here? Oh, I'm sorry, that was the Y range. You get to see all my mistakes here, but that's fine. It's always good to see how to decipher things going wrong. So we have the B is the Y, the A, row A is the, column A is the X, and the output range. So we can hit OK. Alright, and the graph was in the way, but it looks like we just went behind it, so we'll just pull this down. Alright, now I'm just going to come down here to this section. I'm just going to change the formatting just so we can see these numbers better. And I'm just going to make this column a little bit wider along with this, this one here. Oops. Okay, now the important values here, and let me make this a little more understandable. Okay, now the important values here, the main important values are these values right here, because they correspond to the value we saw here in the graph, the 33.3706 for the slope for that variable x, and the 47.424 for the intercept. So if I were to use this to make a prediction, for example, let's say that I wanted to predict y if x equals, let's say 14. What I would do is I would say equals that value plus that value times 14, and it would be 94.5, and that, if you look at the graph here and I project out the 14, that looks about right. 94.6. Okay, there's a couple of other things that are here that you don't get with the trend line. One of the most important one, I think, is this R squared value. And without teaching you a lot of regression here, let me just say that the R squared is a measure of fit, And essentially, if I were to explain r squared in a nutshell, think of it this way. These values in the y column vary, right? There's a certain amount of variation associated with them. In fact, if we look at the graph, if we just took these dots and stuck them over on this axis on the left, you could see they'd vary from like 40 something to 90 something. And it would be a certain variation. We can calculate that. Now, one reason for that variation is that x changed, and you can see from the figure here that x changed causing y to change. Now, that changes in x did not describe all the variation, because you see we still vary from this line. If all these values were right on the line, then we would say that the only reason that y varied was because of x. But it looks like the majority of the reason here that y varied was because of the x changes. So that 8.89, let's call it 90%. What we're saying here is that 90% of the variation in y was caused by changes in x. So it's a measure of fit. 10%, technically 11% of the variation in y remains unexplained, but that's only 10 or 11% of it. Okay, so that's how we do regression in Excel.